Hello and welcome to yet another class for class 12 mathematics. Today we are going to start a new chapter, and that is determinants. Now what are determinants? Determinants is nothing but an extension of matrix theory. So we are still in matrix theory. Okay, so now let us talk about determinants. For example, let us have an example, say a square matrix A written as 1 2 3 4, and we say that determinant of A written in this fashion, this indicates determinant of A, and in this case we say that determinant of A will be equal to 1 into 4 minus 2 into 3, and that is equal to 4 minus 6, and that is equal to 2. So we see that determinant of a square matrix is nothing but a number. Determinant is a number. Determinant is a number of a square matrix that indicates the relation between each and every element of that matrix. Okay, so for now it is important to notice that determinant of any matrix is nothing but a number. Okay, and determinant is written in this fashion. So before starting determinants, let us have two important points about determinants. The first point is that determinant of a matrix A is represented as this. So this symbol indicates determinant of A, where A is the matrix for which you are finding the determinant. So this symbol indicates determinant of matrix A. And second point is that determinant exists only in the case of square matrices. Okay, so here we see that determinant is represented in this fashion, and determinants will only exist when the matrix is a square matrix. Okay, so that means this entire chapter of determinants is going to deal with only square matrices. So now let us study why do we study determinants. Why do we study determinants at all? You must have studied in class 9 or class 8 that how to solve system of linear simultaneous equations. So this is just an application of determinants. Why do we study determinants? In order to find the nature of solution of a system of linear simultaneous equations. Let me give you an example. Let us say you have an equation x plus 2y is equal to 6, and suppose there is another equation. So let us say this is a pair of linear simultaneous equation, and you want to know the solution of this or the nature of the solution. So either this set of equations may have a solution, or it may not have a solution, or it may have infinitely many solutions. So we write these equations in matrix form like this: 1 2 3 minus 2, then xy is equal to the right hand side 6 5. So in matrix terminology we express these two equations like this, and as you can see, this here is a square matrix of order 2, and by finding the determinant of this matrix we can say whether this system of equation will have a solution or not. So this is further in your chapter, we will learn about this thing further in this chapter. For now it is important to note that we study determinants because one of the special applications of determinants is to know the nature of solution of any linear simultaneous equation. Okay, so now let's study how to find determinant of any square matrix. From this point we are clear that determinant exists only in the case of square matrices. So how many types of square matrix can be possible? We have already studied square matrix. So we see that we can have a 1 by 1 square matrix, we can have a 2 by 2 square matrix, or we can have a 3 by 3 square matrix, or we can have a 4 by 4 square matrix, and so on. So in your syllabus The syllabus has included up to order 3 square matrix. So this is outside of your syllabus. We will not study it. A 1 by 1 square matrix look like this. It looks like this. It will consist of only one element. A 2 by 2 square matrix will look like this. And a 3 by 3 square matrix will look like this. It will have 3 rows and 3 columns. Okay, so it is clear that determinants are applicable only in case of square matrices, and accordingly we can have 3 types of square matrices. The first one being a 1 by 1 square matrix, that means it will consist only 1 row, 1 column. Next type of square matrix is a 2 by 2 square matrix. It will have 2 rows and 2 columns. And the third type is a 3 by 3 square matrix. It will have 3 rows and 3 columns. In each case we will learn how to find determinant. Okay, let's start our chapter with the 1 by 1 square matrix and let's learn how to find its determinant. So let's consider the first case, the case of a 1 by 1 square matrix. Determinant of square matrix of order 1 by 1. So let us see how a square matrix of order 1 by 1 looks like. Let us say A is a square matrix of order 1 by 1 and it looks like this. Suppose there is an element inside it. So how many rows does this have? It has only 1 row. And how many columns does this have? It will have only 1 column. So R1 and C1 are the rows and columns of this matrix. So it is a 1 by 1 square matrix. And remember this point here, that determinant of a square matrix of order only 1 by 1 is the element itself. Okay, so keep this in mind. This is the formula, or this is the theorem that you should keep in your mind, that determinant of a square matrix of order 1 by 1 is the element contained in that matrix. So this is the point that you should remember. So whatever element is inside that matrix, that is nothing but the determinant of that matrix, if the matrix happens to be a 1 by 1 matrix. Let me give you some examples. For example, if I say A is a matrix given as 1.23, so it has only one element inside it. So what will be its determinant? So determinant of A will be 1.23. Another example, let us say B is equal to minus 516. So this is a matrix consisting of only one element, and that is minus 516. So its determinant will be equal to minus 516. Okay, so now it must be clear to you how to find the determinant of a square matrix of order 1 by 1. Okay, so keep this theory in mind and also take notes regarding this in your note copy. Let us move to the square matrix of order 2 by 2. Okay, so let's move to the next type of square matrix. Square matrix of order 2 by 2. So let's write a typical square matrix of order 2 by 2. Let A is a square matrix of order 2 by 2 given in this form: A11, A12, A13, A14. Okay, so this is a 2 by 2 square matrix. That means it has 2 rows and 2 columns. So this is row number 1, R1. This is row number 2, R2. This is column number 1, C1. This is column number 2, C2. Okay. Now we want to find what? We want to find the determinant of this matrix. Now you might ask me, why have I written these numbers like A11, 12, 13, 14? Where does this number come from? Well, it must be clear to you that these numbers are written in this fashion: A, R, C. where R stands for the row number and C stands for the column number. So in this case, this element belongs to the first row, first column. That is why R is 1. That means first row, first column. So R is 1, C is 1. That's why you are getting 1, 1. For example, for this element belongs to the first row, second column, right? It belongs to the first row, second column. That is why first row R is equal to 1 and second column means C will be equal to 2. Similarly, in this case, this element belongs to the second row. This element belongs to the second row. Sorry, this is not 1, 3. This is 2, 1 and this is 2, 2. Sorry, my mistake. So this element belongs to the second row, first column. So that is why we have a 2 in case of second row, and since it belongs to the first column, we have C is equal to 1. So that is why 2, 1. And here this element belongs to second row, second column. That is why we are having a 2, 2 here. So it must be clear to you where does this number come from. Okay. Now we want to find what? We want to find the determinant of this matrix. This 2 by 2 matrix, we want to find its determinant. So how do we find it? Remember a point. This is known as the step that you must take while finding the determinant, and that step is choose any one column, or you can choose row, and then expand using the given formula. So this step clearly is telling you that you have to choose any one column, or you can choose any one row and then expand that row or column using the given formula. So it is clearly telling you to choose any one column or row. So if you look at this matrix, how many rows does this have? This has 2 rows, right? You have row number 1 and then you have row number 2. And how many columns does this matrix have? It has 2 columns, C1 and C2. So it is ordering you to choose any column, any one column or row. So first let's try row number 1. Let us select the first row. So let us select the first row in this case. Okay. So in the first case, let us select the first row. So the first row contains 2 elements. One is A11 and the other one is A12. So the formula says that determinant of A will be equal to the first element of the chosen row, that is A11. Then you have to multiply this element with -1 to the power a sum of these numbers, 1 plus 1. Okay, then you have to place a determinant here. And what do you place inside this determinant? Okay, then the next step is to hide the row and column to which the element belongs. Okay, the next step is to hide the row and column to which the element belongs. So which element have you taken? You have taken this element right here. So you have taken A11. So this A11 belongs to the first row, first column. So you hide the first row and first column. So this belongs to the first row, hide the first row. And it also belongs to the first column, hide the first column. Which number do you see now? Do you see this number? Yes, you see this number. So whatever number you see, you place inside determinant here. Okay, this is done. Then next step is plus. You choose the second element. You have already placed the first element here. Now it is the turn of the second element, and that is A12. In a similar way, you do it with -1 to the power 1 plus 2. Then place a determinant. Now hide the row and column. Hide the row and column in this case. So this A12 belongs to the first row, second column. So hide the first row and also hide the second column. Now which element do you see now? Tell me. Do you see this element? So put this element in this position. Now we have utilized both our elements here. This chosen row has 2 elements. This element we have put here and this element we have put here. There are no more elements, so this is nothing but the determinant of this entire square matrix. Okay, so let's simplify it, and we have A11 into what is minus 1 to the power 1 plus 1. 1 plus 1 is 2. So what is minus 1 to the power 2? Minus 1 to the power any even number will be 1. So this is 1. Okay. Then you remember, what about this one? Remember, square matrix of order 1 by 1. What was the determinant of a square matrix of order 1 by 1? It was the element itself, right? So determinant of A22 is nothing but A22 itself. Fine. Then we have a plus sign here. Then we have A12 into what is minus 1 to the power 1 plus 2? 1 plus 2 is 3. 3 is an odd number. Minus 1 to the power any odd number is minus 1. So we have a minus 1 here. And then similarly, determinant of a square matrix of order 1 is the element itself. So we have A21 here also. So simplifying it, we have A11 into A22 minus A12 into A21. So this is nothing but the determinant of this matrix. Okay, so let's write it here. So we have found that determinant of the given square matrix is A11 A22 minus A12 A21. Okay, so it's very easy to remember. Just remember this operation. This into this minus this into that, and that will give you this result, and this is nothing but the determinant of this matrix. Now remember, what was the step? Choose any one row or column. So in this case we have chosen the first row, right? You can get the same result if you choose the second row. So let us try by choosing the second row and see if we get the same result or not. Let us try it out. Let us try using the second row. So let us choose the second row this time and see if we get the same result or not. Okay, so the chosen row is row number 2, and let's try to repeat the same step here. So the first element is A21, right? So we write A21, then again minus 1 to the power 2 plus 1, then determinant. Now hide the row and column. This A21 belongs to the second row and it also belongs to the first column. So hide the second row and the first column. What do you see? Do you see A12? See, we have A12, right? So place A12 in this position. Okay, then we are done with this element. The next element is this one. So plus A22, again minus 1 to the power 2 plus 2, then determinant. Hide the row and column, and whatever you see you put it here. So A22 belongs to the second row, second column. So hide the second row, hide it. What do you see? Do you see this element A11? This is A11, right? So hiding the second row and second column, what do you see? Do you see A11? Put A11 here. And now try to simplify this. So you will have A21 into minus 1 to the power 2 plus 1 is 3. So minus 1 to the power 3. 3 is an odd number. So minus 1 to the odd number, minus 1 to the power odd number is minus 1. So we will have a minus 1 here. Then determinant of a square matrix of order 1 is the element itself. So we will have A12 plus then A22 into what is minus 1 to the power 2 plus 2. See, 2 plus 2 is an even number, and minus 1 to the power any even number is 1. So this is 1, and then again determinant of a square matrix of order 1 is the element itself. So we will have A11 here. Now rearranging, putting this part here, we have A11 A22 minus A12 A21. Now compare this result with that one. This result we are getting from selecting the first row, and see, after selecting the second row we are getting this result. Compare these results and see they are both equal. So by selecting the second row you get the same determinant. By selecting the first row you get the same determinant. And it also says that choose any column. Here we have chosen, in the first place we have chosen the first row, we get this determinant. After choosing the second row we get this determinant, both are same. Now if we choose the first column instead of row, if we choose the first column, we will still get the same determinants. Let's check it out. let us select the first column. So this is column number 1. Let us select the first column. Okay, let's try out first column and see if we get the same determinant. So what is the first element? The first element is A11. Then again you have to go for -1 to the power 1 plus 1, place a determinant, hide the row and column now. So A11 belongs to the first row and first column. So hide the first row and hide the first column. What do you see? Do you say A22? Put A22 here. Then plus A11 is over. Next element is A21. So place A21 here. -1 to the power 2 plus 1. You have to add both these numbers, 2 plus 1. Then determinant, hide the row and column. This A21 belongs to the second row, first column. So hide the second row and also hide the first column. What do you see now? Do you see A12? So place A12 here. Okay, now simplify it. You will have A11 into here -1 to the power 1 plus 1. 1 plus 1 is 2, that is an even number, and -1 to the power any even number is 1. So you will have 1 here. Then determinant of this is A22. Then plus A21 -1 to the power 2 plus 1 is 3. So -1 to the power 3 is an odd number. -1 to the power any odd number is -1. So we will have a -1 here. Then this is A12. So here we get A11, A22, then minus A12, A21. So in this case also, selecting the first column also gives me the same result. See, both these determinants are equal. Okay, so for finding determinant of a square matrix, you can choose any row or you can choose any column, and if you apply this formula, you will get the same result. Okay, so this must be clear to you that you have to choose any column or any row, and after choosing that particular row or column, you apply the formula and you will get the same result. Okay, so now let us try to develop a sign convention so that it becomes easier for you. Okay, now instead of first column, if we now select the second column, this was the first column, right? Now let us choose the second column and see if we get the same result or not. Let us choose the second column. So the first element is A12, write A12 here. Then again -1 to the power 1 plus 2. Then hide the row and column. A12 belongs to the first row, second column. So hiding the first row and hiding the second column, what do you see? A21. So place A21 here. Then plus the next element is A22. Again -1 to the power 2 plus 2. Then determinant. Now hide the row and column. A22 belongs to the second row, second column. So hiding the second row and second column, what do you see now? A11. Place A11 here. Now use it. A12 into -1 to the power 3. 3 is an odd number. So -1 to the power odd number is -1. Then this is A21 plus A22 into -1 to the power 4. 4 is an even number. So -1 to the power even number is 1. Then you have again A11 here. So here also you are seeing that it is equal to A11, A22 minus A12, A21. So finally you see that after using any row or any column, you get the same determinant, and this number is known as the determinant of this square matrix of order 2 by 2. Okay, so now let us see how to remember these signs. Selecting the first row, we are seeing that selecting the first row, if we select the first row this time, again we are seeing that determinant of A is equal to A11 into -1 to the power 1 plus 1. Okay, then some determinant, then plus A12 into -1 to the power 1 plus 2, then some determinant. Here you see that this determinant will have two expressions here, and it contains a minus 1 to the power something and a minus 1 to the power something. Accordingly, the power of minus 1 can become even or it may become odd. So accordingly, this will take appropriate sign. If minus 1 to the power is an even number, it will become positive, and if it is an odd number, then it will become negative. So in this case, we are seeing that 1 plus 1 is 2 and minus 1 to the power 2 is a 1. Okay, so it will have a plus sign here, that means it will become plus. So minus 1 to the power 1 plus 1, it is nothing but plus 1, right? So writing 1 here or not writing it here does not matter, just place a plus sign here. What about this one? Minus 1 to the power odd number is a minus 1, so it becomes minus 1 here. So minus 1 here or just placing a minus here, it is the same thing. Okay, so while finding this determinant, we see that this part becomes plus and this part becomes a minus. So we will have a plus here and then we will have a minus sign here, right? In a similar way, what will be the sign here? See, 2 plus 1 is 3 and minus 1 to the power 3 will be a minus 1, right? So it will have a minus sign here. And what about this one? 2 plus 2 is 4. 4 minus 1 to the power 4 will be an even number. So minus 1 to the power 4 is 1. So that means it is a plus here. So see how the sign are changing, plus, minus, minus, plus. Remember the sign while applying determinants. Now for now, how can you remember this formula? How can we remember this formula? This is very easy. How do you remember this formula? If you see a square matrix of order 2, how to remember its determinant? It is very simple. Just multiply this with that minus this with that. This formula you must keep in your mind while applying determinants. Now let us solve some examples so that it becomes clear to you. Write a question. Find the determinants of the following. Number 1, 1, 2, 3, 5. Find the determinant of this matrix. Let us say this is matrix A. So determinant of A will be equal to 1 into 5 minus 2 into 3. Okay. So we will have determinant will be equal to 1 into 5 minus 2 into 3. Okay. So this will be equal to 5 minus 6 and that is equal to minus 1. So this is the answer. That means minus 1 is the determinant of this matrix. Let us have another example. Let us say the matrix B is equal to 1 minus 1 and 2 minus 3. Let us say this is another matrix and you are required to find the determinant of this matrix. So determinant of B will be equal to this into this minus this into that, right? So what is this into this? 1 into minus 3 minus 1 into 2. So this will be equal to 1 into minus 3 is minus 3, then minus minus plus 1 into 2 is 2 and that is equal to minus 1. So determinant of this matrix is minus 1. Okay, let us have another example here. Question number 3. Let us say matrix C is equal to 1, 0, 5, 3. Find the determinant of this matrix. Determinant of this matrix will be, determinant of C will be equal to 1 into 3 minus 0 into 5. So this is equal to 1 into 3 is 3 and 0 into 5 is 0. So this is equal to 3. Fine. Let us have another example. It is very easy. D is equal to minus 1 minus 2 minus 3 minus 4. So what will be the determinant of D? Determinant of D will be this into this, that means minus 1 into minus 4 minus this into this, minus 2 into minus 3. So we have minus into minus is plus, 1 into 4 is 4, minus into minus is plus, 3 2s are 6. 4 minus 6 is minus 2. So this is the determinant of this matrix. So I think it is clear to you now how to find determinant of a square matrix of order 2 by 2. Okay. Now let's proceed to finding determinant of matrix of order 3 by 3. So let me rub it out. Now we are interested in finding determinant of square matrix of order 3 by 3. Okay. Now let us write a square matrix of order 3 by 3. Let us draw a typical matrix here. Let A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Remember what I told you earlier, these numbers are nothing but the row and column numbers. So these numbers are in this fashion RC. So for example, this element, look at this element belongs to the second row and third column. So second row means R is 2 here and third column means C is 3 here. That is why the number 2, 3. In a similar way, all the numbers are arranged in their particular row and column numbers. Okay. So this matrix A has 3 rows, R1, R2, R3, and it also has 3 columns, C1, C2 and C3, right? So this matrix A has 3 rows and 3 columns. So now according to this step applies for both square matrices of order 2 by 2 and 3 by 3 as well. So it is clearly telling you to choose any one column or any one row and then expand using the given formula. So in the first case, let us select the first row. Let us select this row and apply our formula here. So selecting the first row, we say that determinant of A is equal to, what is the first element? It is A11 multiplied by minus 1 to the power 1 plus 1. Fine. Then there is a determinant. Now hide the row and column. See, A11 belongs to the first row and first column. So hide the first row and also hide the first column. What do you see now? Do you see these 4 numbers? Yes. So whatever you see, you put it inside the determinant. So you see these 4 numbers. So write it accordingly. A32, A33. Fine. Then this element is done. Next element is A12. So plus A12, again minus 1 to the power 1 plus 2. Then determinant. Now hide the row and column. See, A12 belongs to the first row and second column. So hide the first row and also hide the second column. Can you see 4 numbers? Yes. One, this number, this number, this number and that number. So after hiding the first row and second column, you see 4 numbers. And these are A21, then A23, then A31, A33. Okay. So this element is now done. The last element is A13. So A13 into again minus 1 to the power 1 plus 3. Then again determinant. Hide the appropriate row and column. A13 belongs to the first row, third column. So hide the first row and also hide the third column. What do you see? Do you see these 4 numbers? So place them here. We have A21, then A22, then A31 and then A32. And this is the formula for determinant of a square matrix of order 3. So this is the formula. So can you find the final value of this? It is very easy. You have to multiply A11 with minus 1 to the power 1 plus 1. Now see, what is 1 plus 1? 1 plus 1 is 2. So minus 1 to the power 2 is 1. So you have 1 in this position. So A11 into 1 into this determinant. So writing 1 here or not writing here does not matter. It is nothing but a plus sign here. So it is plus 1. Okay. So plus A11 into this matrix. Then you have A12 into minus 1 to the power 1 plus 2. what is 1 plus 2? 1 plus 2 is 3, right? So minus 1 to the power odd number is minus 1. So it is nothing but minus 1 here. So placing minus 1 here, or you can place a minus sign here and just rub it out. Okay, so this is plus a11 into this, then minus a12 into this, then what we have here, minus 1 to the power 1 plus 3. What is 1 plus 3? 1 plus 3 is 4, and minus 1 to the power an even number is plus 1. So here you have a plus 1 here, or 1. Writing 1 here or not writing here does not matter, there is a plus sign here. Okay, so you have plus a11 into this determinant, minus a12 into this determinant, then plus a13 into this determinant. So what are the signs here? Plus, minus, plus. So here you remember there is a plus sign here, then there is a minus sign here, then there is a plus sign here. Just remember these signs for now. We will see how to use these signs to find the determinant of this matrix quickly. Okay, so in the first case we have selected the first row, right? While finding the determinant, we have selected the first row, and the determinant we found is this one. So this entire number is nothing but the determinant. Okay, now let us see if we get the same determinant by choosing the second row. So if we select the second row, we will get the same determinant, that is guaranteed. So if we expand this determinant, you will see what we get. We get a11 into, how to find the determinant of this, a22 into a33, a22 into a33 minus a23 into a32. Okay, then minus a12 into, again, a21 into a33, then minus a23 into a31. Fine, then plus a13 into a21 into a32 minus a22 into a31, and this whole thing is the determinant of the square matrix A of order 3 by 3. So this is the formula for finding the determinant of square matrix of order 3 by 3. You will see that it is very hard to remember this formula. Since it is so long, it is very hard to remember. So the best way to remember the determinant of a square matrix of order 3 by 3 is this formula itself. You will see how do we remember it. So that is why I am showing you this plus minus symbols. Okay, so this formula is very long. Let us see if we get the same determinant by choosing the second row this time. So this is the determinant we get by choosing the first row. Let us see by choosing the second row, do we get the same determinant or not. So what is the second row? The first element is a21, then again minus 1 to the power 2 plus 1, then hide the row and column. See, a21 belongs to the second row, first column. So hiding the first column and also hiding the second row. What do you see? Do you see these 4 numbers? So place the 4 numbers here. We have a12, then a13, then a32, then a33, then plus next element is a22, again minus 1 to the power 2 plus 2, again hide the row and column. See, a22 belongs to the second row and second column, so hide the second row as well as hide the second column. Hide the second column. Which numbers do you see? Do you see these 4 corner numbers? So place them here. A11, A13, A31, A33. Okay, the next element is A23. So plus A23, again minus 1 to the power 2 plus 3, then determinant. Hide the appropriate row and column. A23 belongs to the second row, third column. So let us hide the third column and also hide the second row. What do you see now? Do you see these 4 elements? So place them here. A12, A31, A32. Okay, so this is the determinant after finding the after using the second row in our calculation. So if you expand it, you will see that it matches the exact same result here. Do it yourself and see if it matches or not. It will exactly match this equation. Okay, so that means whether you choose any row or whether you choose any column, you will get the same determinant. So in this case, you see this number minus 1 to the power 2 plus 1. What is 2 plus 1? 2 plus 1 is 3. That is an odd number. That means minus 1 to the power odd number is minus 1. So here you have a minus 1, or you can just rub it out and place a minus sign here. Right? Here also you see it is a minus 1 to the power 2 plus 2. So 2 plus 2 is 4. That is an even number. So minus 1 to the power even number is 1. So you may or may not write it here. It does not matter. It is plus 1. So it is nothing but plus A22 into this. Okay. Then minus 1 to the power 2 plus 3. What is 2 plus 3? 2 plus 3 is 5. Odd number. 5 is an odd number. So minus 1 to the power odd number is minus 1. Okay. So whether either you can keep it as minus 1 or you can just place it here also. So placing it here makes it the same thing. So this is minus A21 into determinant plus A22 into this determinant minus A23 into this determinant. So the signs are here like minus, plus, minus. So in the second row we see that the sign comes out to be somewhat like this: minus, plus, minus. Then so you are clear na? You are clear that using the second row you get the same determinant. Okay. What about the third row? If you select the third row, this time the third row, what will you get this time? What is the first element? A31, then minus 1 to the power 3 plus 1, then determinant. Hide the row and column. A31 belongs to the third row, first column. So hide the first column and hide the third row. Which number do you see now? Do you see these 4 numbers? So place them here. Then plus A32, minus 1 to the power 3 plus 2, then determinant. Hide the row and column. A32 belongs to the third row, second column. So hide the third row and also hide the second column. Which numbers do you see? Do you see these 4 numbers? So place them here. Okay, then the last element is A33 plus A33 minus 1 to the power 3 plus 3. Then hide the row and column. This element belongs to the third row and third column. So hide the third row and also hide the third column. Which numbers do you see now? Do you see these 4 numbers? Place them here. Now if you expand this determinant and multiply with this, you will get the exact same result. It is 100% guaranteed. Okay, now let's look at the sign convention here. Minus 1 to the power 3 plus 1. 3 plus 1 is 4. Minus 1 to the power 4 is plus 1. So it does not matter whether you write it here. It is plus A31 into this determinant. Then minus 1 to the power 3 plus 2. 3 plus 2 is 5. 5 is an odd number. So minus 1 to the power odd number is minus 1. So here you have minus 1. So placing a minus sign here will do the same. Okay. And here also you have 3 plus 3 is equal to 6. 6 is an even number. So minus 1 to the power even number is plus 1. So you can just rub it out and here is a plus sign. So the sign convention here you see is a plus, minus, plus. So just remember, is a plus, there is a minus and there is a plus. So see how easy it is to remember the plus minus symbols. It starts like this. You start from the first row. It is plus minus plus minus plus minus plus minus plus. So it is very easy to remember. Okay. So for now, let us say you remember the plus minus signs. And by remembering the plus minus signs, let us solve some problems on determinant of matrix of order 3 by 3. It will be more clear to you. So now, for now, just remember the plus minus symbols here. Take a good look at the plus minus symbols, and we will start placing these plus minus symbols whenever we want to find the determinant of a square matrix of order 3 by 3. Let us take a good look at the plus minus symbols. It starts from this position, plus minus plus minus plus minus plus minus plus. Okay, if we remember the plus minus symbols, then while finding the determinant, you do not need to place minus 1 to the power something, because we have already placed the signs in this position. Okay, so if you remember the signs, you do not need to place minus 1 to the power something. Okay, then you can directly use this formula by placing appropriate plus or minus sign. You do not need to do it for minus 1 to the power. Okay, that is why we have written these signs. Okay, the best way to remember the determinant of a square matrix of order 3 by 3 is this formula. Do not try to remember this formula, it is very hard to remember. Let us solve some problems. Let us solve some problems, and now it will be extremely easy for you to remember it. Write a question. Evaluate the determinant of the following matrices. Okay, number 1, the first example is 1 2 4 minus 1 3 0 4 1 0. Let us say we have a determinant like this. So which row do you want to select? Let us select the first row, right? But before that, do you remember the sign convention? Yes, you should place a small sign convention in rough note, that it is plus minus plus minus plus minus plus minus plus. Now after expanding the determinant, you do not need to place minus 1 to the power. Okay, so let us select the first row. Let us select the first row and expand using the determinant. So if this is this matrix A, if this is matrix A, then determinant of A will be equal to, the first element is 1 into the determinant. Hide the row and column. So 1 belongs to the first row, first column. So hide the first row and first column. What do you see? Do you see these 4 numbers? So place these 4 numbers here. Then there is a 2 here, right? So next number is 2. And what is the sign before 2? Is it minus? So you have to place minus here. Then use the determinant. Hide the row and column now. 2 belongs to the first row. Hide the first row. And it belongs to the second column. Hide the second column. Which numbers do you see now? Do you see these 4 numbers? So place them here. Okay, the last one is 4. And what is the sign before 4? It is plus. So plus 4. Now hide the row and column. 4 belongs to the first row, third column. So hide the first row and hide the third column. What do you see? Do you see these 4 numbers? Place them here. Okay, done. So now this is the determinant of this matrix. It is very easy to calculate. Let us calculate it. This is equal to 1 into 3 into 0 is 0, minus 0 into 1 is again 0. Okay, next minus 2 into minus 1 into 0 is 0, minus 0 into 4 is again 0. Fine. Then plus 4 into minus 1 into 1 is minus 1, minus 3 into 4 is 12. Okay, so here we see that 1 into 0 is 0, then minus 2 into 0 is 0. So here this is 0, 2 into 0 is 0, then plus 4 into minus 1 and minus 12 is minus 13. So we see that it is 4 into minus 13 becomes minus 52. Okay, so we see that the determinant of this given matrix is minus 52. Okay, let's try to solve another example. See how easy it is to find determinant of square matrix of order 3 by 3. So we should practice more and more so that it becomes easier to you. Let us say we have another matrix. This time say let us B is equal to, let's say B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us say this is the matrix. So now after placing the matrix, place the sign convention that we know. It is plus, minus, plus, minus, plus, minus, plus, minus, plus. Just keep this symbol in your mind, or you can just write it in a separate note. Okay, so determinant of B will be, now select the row and column. Which row or column do you want to select? Do you want to select the first row? Okay, let's try to find the determinant using the first row this time. Again, let us select the first row. So what is the first element in the first row? It is 1. Then what is the sign before plus? It is plus 1. So place a plus sign here. Then hide the row and column. 1 belongs to the first row, first column. So hide the first row and first column. What do you see? Do you see these 4 numbers? Place them inside determinant. 8, 9. The next number is 2. So the next number is 2, and what is the sign? It is minus. See, plus minus. So it is a minus here. So place minus there. Then determinant, hide the row and column. 2 belongs to the first row and second column. Which numbers do you see now? Do you see these 4 numbers? Place them there. Okay. The next number is 3. What is the sign? It is plus. So place a plus here. Determinant, hide the row and column. 3 belongs to the first row and third column. So hiding the first row and third column, which numbers do you see? Do you see these 4 numbers? Place them there. Done. This is the determinant. So now simplify this. We get plus 1 into 5 into 9 minus 6 into 8, then minus 2 into 4 into 9 minus 6 into 7, then plus 3 into 4 into 8 minus 5 into 7. Okay, so you can calculate it at home and find the result. So this is whatever number you will get after simplifying it, that will be the determinant of this matrix. Okay, let us try to solve another example. See how easy it is. It is very easy mathematics. Determinant is a very interesting chapter. Let us solve example number 3. Let us say we have a square matrix. It is 1, 1, 2, 2, 0, 1, and let us say we have a minus 1, 2, 3. So let us say this is matrix A. So its determinant will be, now remember the sign convention, place the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so now determinant of A will be equal to, which row do you select? Well, okay, in previous examples we have chosen the first row, right? This time let us select a column. Let us say we select this column. You can choose any row or column. So let us, for this example, let us select the column 2. So what is the first element? It is 1, right? It is 1. And what is the sign before 1? See, there is a minus sign. So place minus 1 here. Then determinant, hide the row and column. 1 belongs to the first row, second column. So hide the first row and hide the second column. Which numbers do you see now? Do you see these 4 numbers? place them there. 2, 1 and minus 1, 3. Okay, the next element is 0. So place 0 here. See, there is a plus sign, so that is why I have used plus here. Okay, then determinant, hide the row and column. See, 0 belongs to second row, second column. So hide the second row and second column. Which numbers do you see? Do you see these 4 numbers? Place them there. 1, 2, minus 1, 3. 1, 2, minus 1 and 3 I have placed there. The next number is 2. So place a 2 here. What is the sign? It is minus. So it's a minus 2 into determinant. Now hide the row and column. 2 belongs to the third row and second column. So try to hide the third row as well as the second column. Which number do you see now? Do you see these 4 numbers? So place them there. 1, 2 and 2, 1. And that is nothing but the determinant of this matrix. To try to simplify it, it is minus 1 into 2 into 3 minus 1 into minus 1. Okay, then plus 0 into 1 into 3 minus 2 into minus 1. Okay, then minus 2 into 1 into 1 minus 2 into 2. So you can simplify it and find a number, and that number will be your determinant. Okay, so if you simplify it, you will get a number, right? So here you have, this is equal to minus 1 into 2 into 3 is 6. 6 and minus minus is plus 1. Okay, then plus 0 into something is 0. Then minus 2 into 1 into 1 is 1. Minus 2 into 2 is 4. So here you have 6 plus 1 is 7. It is minus 7. Then minus 2 into 1 minus 4 is minus 3. So it is minus 7 plus 6, and that is equal to minus 1. So minus 1 is the determinant of this matrix. So now we have solved several examples on square matrices of order 3 and we have found their determinants. Let us look at a very interesting case. This is a very important point that you should remember while considering square matrices of order 3 by 3. I want to make a very important point here. And try to give it 3 stars because it is very important for you to know. Let us take the example of a square matrix of order 3. Let us look at a specific example. Let us say we have matrix A is equal to 1, 0, 0, 2, 3, 4, 5, 6, 7. And while finding the determinant of this matrix, we see that we are writing, if you are selecting the first row, place the sign convention plus, minus, plus, minus, plus, minus, plus, minus, plus. So select the first row, the number 1, then hide the row and column. 1 belongs to the first row, first column, hide the first row, first column. You see 3, 4, 6, 7. So write them here. The next element is 0. If you are selecting the first row, right? Selecting the first row, the next element is 0. Okay, and there is a minus sign here, so minus 0. Determinant, hide the row and column. 0 belongs to first row, second column. So hide the first row and hide the second column. Which number do you see? 2, 4, 5, 7. So write them here. Then third element is plus 0. Plus sign is there, so plus. And then hide the row and column. 0 belongs to the first row, third column. So hide the first row and hide the third column. Which numbers do you see? Do you see these 4 numbers? Place them here. And this is nothing but the determinant of this matrix. Now, do you notice a very strange thing here? Tell me what is the strange thing here. Tell me. Take a minute to think about it and find a strange thing in this equation. Take your time. I am giving you 1 minute to think about it. What is the strange thing that you see in this determinant? Okay, time is over. The strange thing that you see is that this entire thing becomes 0. This entire thing becomes 0 because it is getting multiplied with a 0. And this entire thing becomes 0 as well. Okay, so here you have a 0 and here we have a 0. So that means you can just rub them out because it is 0. They are not there. Okay, so the only determinant that matters is this one. So it is useless to calculate all the other determinants, right? Why? Because both of them were multiplied by 0. So whole of them become 0. That means they are not here. They are nothing. So in this case, for this special matrix, you are getting a single determinant, and if you calculate that determinant, you will get the result, and that is 3 into 7 minus 4 into 6, and that is equal to 21 minus 24 equal to minus 3. So minus 3 is the determinant of this matrix, right? Okay, so now see, can you notice that the calculations have become significantly easier this time, because this time you are just calculating determinant for only one matrix here. You do not calculate the other two matrices because they were getting multiplied by 0. So how is this possible? This is possible because in this matrix of yours, you see a row or a column with number of zeros present. So in the first row you see there are 2 zeros present. Okay, so whenever you see such a matrix, always select a row which has the maximum number of zeros, and if you do so, what will happen? You will significantly reduce the complexity of calculations. So this very important point is that if you notice that your matrix contains zeros, then select that row or column which has the maximum number of zeros. So this is the very important point, or you can say it is a trick to reduce the calculations. Okay, so reduce the complexity of calculations. What you should do, you should select that row or that column which has the maximum number of zeros. So in this particular matrix we see that only the first row contains 2 zeros. So you select the first row and apply the formula. Okay, let us see another example. So you remember this point and you keep it noted in your note copy. Let us have another matrix and tell me which row or column should I select. Let us give you another example. 1, 2, 0, 3, 0, 5, 9, 0, 3. Tell me which row or column should I select this time. Take a minute, take a very good look at this example and tell me which row or which column should I select. Okay, the first row contains only 1 0. Okay, the first row contains only 1 0. Second row contains only 1 0. Third row contains only 1 0. First column contains no zeros. Second column contains 2 zeros. And third column contains only 1 0. So the which column has maximum number of zeros? This column has the maximum number of zeros. So you will select this column and try to find the determinant using that column. So this will significantly reduce your calculations. Okay, let us give you another example. Let us say B is equal to 100, 503 and 991. Which row or column should you select this time? Tell me. See, the first row contains no zeros. Second row contains 2 zeros. Third row contains 1 0. first column contains 2 zeros, second column contains 1 zero, and the third column contains no zeros. So we see that the second row contains 2 zeros, and all at the same time the first row also contains 2 zeros. So you can either select the first column or you can select the second row and proceed with the calculation. It will significantly reduce your calculation. Okay, so you will get the determinant of this matrix very easily. That means you will not need a large number of calculations to find the determinant of this matrix. It is very easy. Okay, so we have learned today how to find determinant of square matrix of order 1 by 1, 2 by 2 and 3 by 3. Before concluding this class, let me just revise some of the examples that we have studied. Let us say we have a matrix 2. What is the determinant of this matrix? Determinant of this matrix is 2, because it is a 1 by 1 square matrix of order 1 by 1. So we have known that determinant of square matrix of 1 by 1 is the element itself, that is 2. In the second case, we have learnt if we have a matrix like this of order 2 by 2, what is the determinant? Its determinant looks like this, and that is equal to 1 into 4 minus 2 into 3. So that is minus 2. Minus 2 is the determinant of this matrix. In the third case, we have learned how to find determinant of matrix of order 3 by 3. 1, 2, 3, 4, 5, 6, 1, 1, 2. So how to find the determinant? You select any row or any column. In this case, if you select the first row, then also remember the sign convention: plus, minus, plus, minus, plus, minus, plus, minus, plus. Selecting the first row, it is 1, plus 1. Then hide the row and column to which it belongs, 5, 6, 1, 2. So write 5, 6, 1, 2. Next number is minus 2. Here place it. Then hide the row and column. We see it is 4, 6, 1, 2. Then the next element is 3, plus 3, and hide the row and column. We see 4, 5, 1, 1. Then it is 5 into 2 is 10, 6 into 1 is 6, then minus 2, 4 into 2 is 8, minus 6 into 1 is 6, then plus 3, 4 into 1 is 4, minus 5 into 1 is 5. So this is equal to 10 minus 6 is 4, minus 2 into 2 is 4, plus 3 into minus 1 is minus 3. Okay. So this is equal to minus 3. So minus 3 is the determinant of this matrix. And in the fourth case that we have studied today, we have seen that if we are faced with a matrix that has zeros in it, then the row or column that we should select is that row which contains maximum number of zeros. If we do that, it will reduce our calculations. So place the sign symbols here: plus, minus, plus, minus, plus, minus, plus, minus, plus. Selecting the first row, it is 1. Hide the row and column. 1 belongs to first row, first column. So hide the first row, first column. What do you see? 3, 4, 6, 7. And the rest is 0. So I can place minus 0 into some determinant, then plus 0 into some other determinant, and that would be 0. So I am not writing them. So in this special case, if I select this row with the maximum number of 0, I am facing this determinant only, and that is equal to 3 into 7 minus 4 into 6, and that is equal to minus 3. So now that's it for today, and in the next class we will try to move into some more advanced topics on determinants. So before concluding this chapter, I want to give you some homework so that you can practice at your home several examples on finding determinants of matrix. So here is the homework for you. Find the determinants. Number 1, determinant of 2.2. Number 2, determinant of minus 12.6. Number 3, determinant of 1059. Number 4, determinant of 129 minus 7. Number 5, minus 1, minus 2, minus 3 and minus 1. Number 6, 1, 2, 3, minus 1, 0, 5, 6, 0, 2. Number 7, 1, minus 1, minus 2, 0, 0, 5, 1, 2, 3. Number 8, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. Okay, so these are 8 examples and I leave them to you so that you can practice at your home and find their determinants. Okay, so that's it for now. We will meet in our next class. Thank you so much.